A particularly powerful feature in Excel for data summary and visualization is the pivot table. A pivot table is a tool that facilitates the calculation, summary, and analysis of spreadsheet data. Today, I'm going to demonstrate how to create, build, and work with pivot table values using the LeadingCausesbyState.xlsx file. And I hope you can follow along. First, to create a pivot table, you're going to want to open the desired Excel spreadsheet and then select the cells containing the data to include in the pivot table. A helpful hint is that data should be organized into columns with a single header row, which is exactly what we see in the Leading Causes by State spreadsheet data. So I'm going to go ahead and click within the data area. I'm running a Windows machine and I'm using Excel 2016 for Windows. So I can use the shortcut Control A, and that'll highlight all of the cells that are contiguous that include our data. Next, I'm going to navigate to the Insert tab and then click Pivot Table, which is right under File on the upper left-hand corner of the screen. This opens a dialog box where we can specify where Excel should place the pivot table. You can select New Worksheet to place the pivot table in a new worksheet, or Existing Worksheet, and then select where you want the new pivot table to appear. In this case, let's take a look at it in our existing worksheet. So I'm going to click the button for Existing Worksheet. Then in the location field, I'm going to click, and then I'm going to click the cell that I want the pivot table to populate at. So I'm thinking I1 looks good here. And I'll click OK. And we have a pivot table. To add a field to the pivot table, you just want to select the field name checkbox in the Pivot Tables Fields pane, which is on the right-hand side of the screen. For example, maybe we want to look at year, cause name, which is the cause of death, and the age-adjusted death rate. So I click the checkbox for year and for cause name, and then for age-adjusted death rate. Excel organizes fields into their default areas. Non-numeric fields, so categorical fields, are added to rows. Date and time hierarchies are added to columns, and numerical fields are added to values, such as year and age-adjusted death rate. To move a field from one area to another, drag the field to the target area. For example, you can click and drag year to the columns area to create a column for each year in the data set. So again, clicking on year and dragging it down to the columns area until I see a green line show up, which means that Excel is making that connection, that it's prepared to do what I want it to do. So now our table is a little bit bigger. I'm going to scroll over a little bit just so you can see. So we now have these sum of year columns, which have some very big numbers that don't seem to make much sense, as well as columns by year for age-adjusted death rate for each of our causes of death. So it seems like we're on the right track, but we might have a little bit of cleaning up and formatting to do here. So by default, pivot table fields that are placed in the values area will be displayed as a sum total. And we actually see this with other tools as well. This is what Tableau often does. If Excel interprets data as text, it's displayed as a count of occurrences. But you can change the calculation by first clicking on the arrow to the right of the field name and then selecting the value field settings option. So let's take a look. In the values area, we're going to click the down arrow for sum of age adjusted death rate and click value field settings. And now this launches a dialog box where the calculation may be adjusted. So in this case, we might be much more interested in the average. So where it says summarize value field by, sum is the default, average is the third item down, click average, the custom name for the value field setting also changes to reflect that it's now an average as opposed to a sum. I'll click OK, and that changes the data for our year columns that represent the age-adjusted death rate. So this seems to give us better information about the age-adjusted death rate for each cause of death by year. But the pivot table is still large and a bit messy. We can work with the specific fields to further filter and refine the content in the pivot table. And I suggest trying some or all of the following. First, in the values area, we might want to click sum of year and just click remove field. We want to see our age-adjusted death rate organized by year, but summing up all of the values for year isn't terribly helpful or instructive. So we're just going to remove this field entirely. So our table is a little bit smaller now. Scroll over a little bit here and we can see that we now have columns for each of the years between 1999 and 2016. And it illustrates the average of the age-adjusted death rate for each of our causes of death. So we see that our average values round out to quite a few decimal places. And that level of precision might not be terribly helpful for us. So we can adjust the formatting of our numbers for average of age-adjusted death rate. So to do this, we can go to the values area and click average of age-adjusted death rate, click value field settings, then click the number format button, then select number, the second item down for category, and then set it to show values to 2 decimal places. And this is usually the default settings. So you might not actually have to do anything. Just make sure that we're going out to 2 decimal places. Click OK. Then we click OK on the next dialog box as well. And our table is now a little bit more compressed. The numbers are a little bit more manageable and easier to see and read. So we're definitely moving in the right direction here. Next, we might want to refine some of the causes of death that we're looking at. Chiefly, the very first row represents all causes of death. And this is a bit of a complicated value to keep in the table because it essentially double counts all of the causes, all of the other 10 causes in this data set plus additional causes of death, but it basically acts as a double counting. So we want to just remove that all causes line item from our rows. So we can go to the cell called row labels, click the drop down menu, and then we can see all of the different categories in this variable of cause of death name. And I just want to unselect all causes and click OK. And now the all causes has been removed from the table, and we're left with our 10 leading causes of death with the age-adjusted death rate averaged by year from 1999 to 2016. Then in column AB, we have the grand total, which is essentially the average calculated over that time period. Whereas the grand total row, row 13, is the average age-adjusted death rate for those top 10 causes of death by year. To look at changes in the age-adjusted death rate over time, we could try applying conditional formatting to each row of data. For example, we can highlight the age-adjusted death rate for Alzheimer's disease from 1999 to 2016. After doing that, we can navigate to the Home tab, select Conditional Formatting, Color Scales, and we'll take a look at this red-white color scale. So I clicked that, and now we see that a color gradient ranging from the color white to a dark red appears across the time period for Alzheimer's disease. I excluded the grand total because the grand total is the average of our averages over time. So to include it would effectively be to do some double counting that we don't necessarily want to do. Although we can see that in 1999, the age-adjusted death rate for Alzheimer's disease was 17.48, and by 2016, it had nearly doubled to 30.91. And we can see with this color gradient how and where this death rate gradually increased over the span of 17 years. And it looks like it fairly consistently increased, but we could use something like a spark line to really see it. The color is enough to give us a sense that there's something going on, but maybe another visualization type would be a little bit more helpful. So to add a spark line, navigate to the Insert tab, click Line, which is sort of near the middle in the Insert ribbon. Then for the data range, click the data range field, and then highlight those age-adjusted death rate values for Alzheimer's disease from 1999 through 2016. Then, clicking in the location range field, we select the cell where we want the spark line to appear. I'm going to go with AC3. Click OK. And now we see the spark line that illustrates the trend of age-adjusted death rate for Alzheimer's disease. So let's repeat the process of applying conditional formatting and spark lines one more time. And this time, we'll look at cancer. So the reason why I applied the conditional formatting just to the Alzheimer's disease row It's because you may notice that the scale or the age-adjusted death rate tends to be consistent within conditions, but not across conditions. So while Alzheimer's disease takes a range of 17.48 through 30.91, we see that cancer is on a bit of a different scale, where in 1999, the age-adjusted death rate for cancer was 201.45. And the lowest value it seems to take is in 2016 at 158.11. And if we just consider that range, it's moving in the opposite direction of Alzheimer's disease, but it also seems to appear at a different magnitude. So let's apply conditional formatting and check out a sparkline to look at cancer trends in terms of age-adjusted death rate. So I'm going to highlight the row of data for cancer from 1999 to 2016. Click conditional formatting, color scales. We use that same color scale, red to white. And what we see is sort of the exact opposite trend that we see with Alzheimer's disease. I think that's pretty interesting. I don't know about you, but just about everyone's been touched by Alzheimer's disease. And it's alarming to see that over time, the age-adjusted death rate is increasing. On the other hand, just about everyone has also been touched by a friend or family member with cancer. And just by looking at the conditional formatting with the different intensity of the shade of red, it seems like things are moving in a pretty positive direction for cancer. But let's throw in a sparkline just to support the conclusions that we're drawing from our findings here. So navigate to the Insert tab, click Line. Our data range is going to be J4 through AA4. And our location range is going to be AC4. Click OK. And we can see that line is a very, very, very steep and pretty linear negative relationship that over time, the age-adjusted death rate for cancer is plummeting. I think that's pretty exciting news. I'm kind of glad to hear that. So I challenge you to repeat some of these different steps for some of the other causes of death in the data set to see how the trends compare. And I also encourage you to try to add some different variables to the data set with different levels of aggregation. Maybe you want to compare number of deaths or death rates between a selection of maybe 5 states, maybe Pennsylvania, Maryland, West Virginia, Ohio, and Virginia. That could be something that you try. And if you make any interesting discoveries, you should definitely drop me a note so we can discuss them. I hope that you found this helpful, and just let me know if there's anything else that you would like to see demonstrated or drilled into. And I will be happy to put together a tutorial and record another video. Until next time,